department given the opportunity. So I feel so much proud that now it is that webinar we are conducting here. So we have seen that many different talents we are going to see here. And flying colors, like as a garden, we have seen that same water is there, and it is on the garden having different colors are there, means unique talents are there. In a garden, suppose same water is there, but having different colors of flowers are there. Like in this way, here also a teacher is going to you and guide you, and we are going to see at that end of different talents are there, different your unique talents are there, which is has their things, unique talents are there, and all are based on your experience, whatever teachers has seen you, whatever you have explored. Like in this way things are there. So I am going to start with a quote, that is that, tell me, I forget; teach me, I may remember; involve me, I will learn. So all of you have seen that sometimes something your father and mother is telling to you, you are going to the market or any another work is there. Sometimes you forgot it because they have told it, orally they have told that. That's why you have forget. While they teach, the teachers are teaching to you, many concepts are there, like as your homework or other things are there. While the teachers is asking you that, have you submitted? Sir, I forgot. Like in this way, the teacher when teach you, that you sometimes you have remember, and for the first few times you also forget it. But when you are involved in the activity, suppose any things you involve in activity, you learn. Like as in an example, nowadays we are 21st centuries are there, and many skills are developed there. Nowadays, CBSE has emphasis the experiential learning as well as the art integration learning. Here, whatever the project we have or seminar we are organized here by our Jivan sir. So here we are going to see that many experiential learnings and art integration learning, means you are come with a different art integration manner to introduce the mathematical concepts are there. So in 21st century, education is at a higher purpose for developing the knowledge as well as the skill. For one example, I am telling, what is the experiential learning? All of you know the riding of bicycles. Slowly you are riding the bicycles are there. Suppose you want to speed it, means you want to जोर से चलाना चाहते हो, तो at that time you have to some position, you have to leaning position towards move forwards, the leaning positions are there. Definitely the riding of that bicycles will be more will be there. So what is here there? Now we have understood that, we have experienced it, that while we are sitting normally we have riding the bicycle, it is not moves so much fast, but when leaning towards that forward, that it is obviously side speed will be increases. Like the concept is also there also. So if we will little involve, little experience, little leaning towards that education, definitely we will move go for more progress there. So learning is nothing but it is a reflection of doing. Whatever you are doing, the reflection in examination, we are doing that reflections is there. How much you are doing, how much you are practicing, how much you are involved in that. That's why learning. We are going to do the examinations are there. Learning is there. So learning is nothing but a reflection of doing. Like in the examination is there. Suppose you have did some mistakes are there. Whatever the mistakes we have come now first, after that same things will don't repeat in the future. That is called your experiential learning. In example, the simple manner is there. Whatever the mistakes we are doing at present, it will not further repeat in the future. That is your called experiential learnings. So experiential learning are plays an important role is there, and it is being a mathematics seminar. And I am not going focus about the mathematics. There many mathematicians has a lot of contribution towards the field. When the mathematics day will be there, definitely we will focus about this. And at that time we will highlight it also more there. So basically I will here to you see that all of you have that unique talents, just you explore it. Whatever the talent within you has God has given, and by the have blessings of the teachers, whatever you are getting here, little explore, little involve and practice it, definitely you will do a success. So with this, I will have a great day here. This much is only there because it is your day, so we will not much time will take here. Definitely have a great day. Thank you, madam.
Thank you so much, sir, for your wonderful speech. According to John Quincy Adams, if your action inspires others to dream more, learn more, do more, become more, you are a leader. And we have such type of leader with us. He is none other than the leader of our Tata DAV Public School Joda, as well as the leader of our mathematics department, our most respected and most eloquent, energetic principal, sir. B. Sai Siva, sir. I would like to call upon our principal, sir, to say few words to encourage our students. It's over to you, sir.
Good morning, one and all. At the very outset, I would like to extend my happy National Sports Day for each and every student and the teachers here, because sports, we feel that maths is also a one kind of sports. Every day we get thrill and we respect some rules and follow and get some solution. So good morning once again, and thanks to the Department of Mathematics for organizing such an excellent and very much required platform for our students, because as we all are in the 21st century, and here the expression is matters a lot. You may be having a lot of knowledge, but if you are not going to bring it in your action and to presentation, then there will be no use of those knowledge. So my dear, all the students, they might have taken a lot of not pain, effort during these days to come up with good presentations and some unique way of presenting the same content what we have learned in our schooling time. So I'm very much eagerly waiting to see some of the presentations which will I also learn, and many other students who are on this platform, they will learn. So don't be nervous, just enjoy your present moment and try to give your presentation with lot of clarity. Confidence will automatically will come. If you understand the content, you can easily able to present also in front of us, and that is all the aim of this webinar also by your math department, that students may be having a lot of knowledge, but whether they will be bringing to the experience of others with their whatever knowledge they are having. So that is why we all want to guide, groom, and definitely support you. So all the best to all the presenters, and just enjoy, because the new education policy is always emphasizing on the skill to represent, skill to present, all these things, and creativity, because most of the people in their mind, they used to think that these mathematics students are only think from their heart, from their head. They are not involving their heart. But this is the place when you bring some creative things with blending of some art and experiential learning, new creations will come. And their imagination is required, your heart is required. So all these things we need to respond to the world कि हम मैथ टीचर्स और मैथ स्टूडेंट्स दिल से भी बहुत कुछ सोचते हैं और दिल से भी बहुत कुछ एक्सप्रेस कर सकते हैं. केवल दिमाग का ही काम नहीं है मैथ्स में बहुत ज़्यादा दिल का भी इन्वॉल्वमेंट होता है, क्योंकि without the passion, without the emotion and love for this subject, you all could not have thought of mathematics will be an interesting one. So सबको बहुत मजा आ रहा होगा और मैं भी बहुत मजा लेता हूँ, ले भी रहा हूँ. So let's enjoy the math, because आपका जो टॉपिक भी है, जो नाम दिया गया है, that is also very rightly मैथ एक्सप्लोर के लिए जो भी हमारे मैथ्स में और नएपन के साथ दिखा सकते हैं या कुछ जोड़ सकते हैं, it will be a great contribution to the world of math. So all my good wishes, and thanks to the Department of Mathematics entire team who have not only thought of this webinar, also at the background they might be helping all the students and guiding all the students to create a math lovers in our school. So everyone should have love and respect for this subject, because it is not only a technical one, it is very much required in this hour of moment. So best of luck, good wishes from my side, And thanks to Maths Department once again. Over to Parasmita. Thank you, ma'am.
Thank you so much, sir, for your valuable words. Now, I request our beloved principal, sir, to say some words of appreciation to our students of class 7, Abhipsa Mishra, who stood third position in state level competition by doing a mathematical modeling on properties of angles of a triangle and a polygon. Sir,
Yes, of course. Yes, of course. I had a talk with her parents.
Abhipsa, if possible, turn on the
I
video.
got, yes, Avitsa, are you there on this platform? The other day I have. Good morning, Avitsa. Once again, congratulations for your remarkable effort and thought and coming up with the practical project, which is selected not only in district level, then state level, and in state level it stood first, which is really a great moment for the Tata DAV as well as the students who are looking at you. That yes, if you sincerely put some effort and what we say engagement with some math, your world is going to not only respect, they will take it with a lot of love and appreciation. So congratulations for your effort or endeavor, and we are looking forward in future also. You are not going to stop here. You are keeping on thinking how to bring the models of mathematics or mathematics properties in the form of model or in the form of very easy tools and techniques, so that the juniors and the students who are struggling in math, they will also enjoy math and they will also take math as a part of their academic. So thank you, Abhit sir, and I hope your health is now better. That day you was not well. How are you now? How is your health?
Sir, I'm feeling better now.
Very good. So extend my congratulations to your parents, and you made not only you proud, we all proud. So God bless you, beta. Keep it up. And all the other bhaiya and the didi, they are also looking at you on this platform. Yes, you are going to bring some change and smile on their face because they are also engaging themselves in this kind of thing. So let's hope in future days many Sakuntala Devi and Ramanujan will going to come forward to contribute something in the field of math. God bless you, beta.
Thank you, sir.
Keep it up.
Thank you, sir.
Over to Parasmita.
congratulations, Abhipsa.
Thank you,
Thank,
ma'am.
thank you so much, sir, for your inspiring words, and your constant motivation helped us to grow more and more. Now, the time has come to present our projects by our students. So get ready, students. Now it is time for the first group. It is not enough to have a good mind. The main thing is to use it well. This was the thought of René Descartes, the father of coordinate geometry. With this thought, our students of class 10 are going to present a project on coordinate geometry. Let's welcome the SAS group, that is Shruti Sangita, Ashish Das, Siddhant Patnaik, Srishti Mohanda, to present their project on coordinate geometry. All the best, the SAS group, and rock the stage. Get ready, the second group, with your project.
Good morning to all.
Namaste.
Hello.
A warm welcome to all of you.
We have made a video related to coordinate geometry. This project is guided by Jivan Jyotisa. Now let's enjoy it.
Hope the audio is coming.
Yes, sir. Yes, sir.
Yes, sir.
We, the team SAS Congruence, we welcome you all in this Maths at Integration 2021-2022. Today, it's our maths expedition that resumes as we explore the western, central, and the eastern parts of maths. Today's project theme is based on art integration and experimental learning. The name of our project is on coordinate geometry transformation by GeoGebra. Our team name is SAS Congruence Group. SAS stands for S for Srishti, A for Asis, S for Shruti Sangita, and S for Shridhant. Now, I would request Shridhant for further explanation.
Thank you, Srishti. Our occasion begins when our journey meets our destination. We welcome to you all to coordinate plane. Yes, it is rightly said that there is a geometry in the hewing of strings. There is a music in the spacing of spheres. Geometry is not limited with math, and its shape is even broader than the hewing of strings and the music of sphere and space. Our theme is based on coordinate plane, and we are going to present our creativity on transformation by GeoGebra. Now, my friend Sangita will explain more on this.
Our theme, let's get a glance on our context part. First, we will discuss introduction to Cartesian coordinate plane. Second, we will discuss transformation. Here it is divided into 4 parts, that is rotation, reflection, translation, enlargement. Third, we will discuss about art integration based on math. Last but not the least, we will discuss about the conclusion part. Let's move on to the first topic, introduction to Cartesian coordinate plane. What is coordinate geometry? The branch of mathematics that deals with the points of coordinate planes is said to be coordinate geometry. Moving on to Cartesian plane. It was first introduced by a French mathematician René Descartes in 1673. The coordinate plane is divided into 4 quadrants. First quadrant, both the coordinates are positive. In the second quadrant, x coordinate is negative, whereas the y coordinate is positive. In the third quadrant, both the coordinates are negative. In the fourth quadrant, the x quadrant is positive, whereas the y coordinate is negative. I will request my friend Ashish for further explanation.
Thank you, Sangita. Now let us know some basic concepts related to coordinate geometry. Coordinate axes are of two types, x-axis and y-axis. X-axis is known as abscissa and it is also known as x-coordinate. Y-axis is known as ordinate and it is also known as y-coordinate. In a graph, distance from x-axis is known as y-coordinate and distance from y-axis is known as x-coordinate. Now let us know some formula related to coordinate geometry. First one is distance formula. Distance between the points AB is given by x2 minus x1 whole square plus y2 minus y1 whole square. Distance of point A from origin is equal to x square plus y square. Second one is section formula of a point P of xy, which divides the line segment AB in the ratio m1 and m2, is given by x equal to m1x2 plus m2x1 by m1 plus m2, y equal to m1y2 plus m2y2 by m1 plus m2. The midpoint P is given by x1 plus x2 by 2 and y1 plus y2 by 2. Then area of triangle equal to area of triangle ABC of coordinates A x1 y1, B x2 y2, C x3 y3. Area equal to half whole x2 whole y2 minus y3 plus x2 whole y3 minus y2 plus x3 whole y1 minus y2. Now we will know about transformation. What is a transformation? Literally, when we talk about transformation, we mean about change. Change is necessary in our society, but it isn't all bad, not by any means. To keep us moving, to keep us growing, to keep us interested, imagine a life without any change. It will be static, boring and dull. So let's learn transformation in math. It is a process which manipulates a polygon or other two-dimensional object on a plane or coordinate system. It describes how 2D figures move around a coordinate plane. Here we have two important terms, namely pre-image and image. Pre-image is the 2D shape before any transformation, and image is the 2D figure after transformation. There are four types of transformation. They are rotation, reflection, translation, and dilation. Now let's discuss all the transformation one by one.
Our first type of transformation is rotation. The image is a pre-image rotated around a fixed point. A turn is called rotation. Our first type of transformation is rotation. Here I will draw a polygon. I have taken triangle as A, B, C. You can take any figure you want. Then I will choose rotate around a point. According to this point, I will select the figure, choose the central point from where I want to rotate, and then angle of rotation. You can take any measure you want. Then I finally got my image from the premise. The image is got 90-degree rotated according to the angle. The demonstration correctly defined that the rotation and the point around which 2D shape rotates. You can easily see rotation in the coordinate Cartesian plane.
Second type of transformation is reflection. What is reflection? The image of is a mirror pre-image F-flip is called reflection. Here we have done a practical video. Let's see that. Our second type of transformation is reflection. We will take a polygon. I am drawing a triangle ABC. You can draw any figure. Then choose line segment and draw it on the coordinate axis where you want the image to reflect. Then choose the reflect about line option. Then choose the image you want to reflect. Then click on the line segment drawn. Finally, I got the image from the pre-image. This image has got reflected on the other side of the axis I choose. This demonstration correctly defines that by using the reflection and by choosing a coordinate axis where the reflect image, you can easily reflect the image on the coordinate Cartesian plane.
Our third type of transformation is translation. The image is offset by a constant value from the pre-image, a slide. Now let's see a practical translation video through GeoGebra. Our third type of transformation is translation. As usual, we will draw a polygon. I have drawn a triangle named ABC. Then I will choose the translate it by vector option. According to this option, I will select the figure, then choose the point from where I want to translate. You can take any measures for this. You can take 1 upward, 2 downwards, 2 units up and 2 units down, 3 units up and 3 units down. Finally, I will take 4 units up and 2 units down. Now this image I got is different from that of the pre-image. This image has got translated 4 units up and 2 units down. This demonstration correctly defines that the translation moves the figure on the coordinate plane without changing the orientation.
Our fourth type of transformation is enlargement. Definition: the image is the large or small version of the pre-image. Shrinking or enlarging is known as dilation or enlargement.
Our fourth type of transformation is enlargement. We will take a polygon. I am drawing the triangle ABC like this. Then take a point with a measure you want. I am taking like this. Then choose the option dilate from point and choose the figure you want to do enlarge. Then click on the point and give a factor. I am giving a factor 2. Finally, I got my image from the pre-image. This image has got enlarged. This demonstration correctly defines that by using enlargement and a point for including factor which make a new image, you can easily enlarge a shape on coordinate Cartesian plane.
Each and everything in the universe has its own culture and its history. Every architecture is built with its art. Let us also relate math with the art integration. Here we have drawn some drawings using coordinate plane. Now I would request my friend Srishti to point us the last part of our project.
Thank you, Shridant. Now I am at the last part of our presentation, that is the conclusion part. So let's move on. In conclusion, I believe life would be a struggle without maths, and I am thankful that it exists. A transformation is an operation that moves or changes an object to produce a new figure. The new object is called the image. As said by my friend Ashish in the introduction, that the transformation is about change. It is aptly described the transformation in our real life too. What is then left else in the real life examples? The invention of the Cartesian coordinate can be considered as a blessing for the mankind in this modern world. It is also called as the analytical geometry, describes that the link between the geometry and the algebra through graphs. This system has made it possible to locate any object in the earth or space or any other Milky Way galaxy. Thank you, Principal Sir, for your valuable time. Thank you, Jiban Sir, for organizing this maths art integration. On this, we are able to exhibit our talents using many medium. Once again, thank you all of you for having a patience listening. Thank you all.
Thank you so much, all the presenters of the SAS group.
By
It is,
reflecting back on.
hello?
Yes, ma'am,
Thank-
just a little bit.
Huh? Okay. So, it is such
Ma'am,
a
our last
wonderful.
part is left. Yes, ma'am.
Last
I'm
part?
just. Yes,
Okay,
ma'am.
okay, okay. Okay, you carry on. Okay, carry on.
While reflecting on my maths project, I have got the importance that the maths has involved not only in our project but also in our lives. Thank you.
Okay. Very good
Thank you all.
presentation. Very good presentation. Keep it up. Nicely executed and nicely explained how the transformation is happening. So it is time for the second group. Maths is for. It teaches you life and death information. Like when you are cold, you should go to the corner since it's 90-degree there. With this thought, our next group of students, Ananya Kumari, Survi Sahu, Khushi Jaishwal, Sivani Sahu, Vandana Aradhana of class 9 are going to present their project on topic Schools of Maths and Class of Solids. And please welcome all the presenters of this group. The stage is ready for you. It's time to enjoy the labor you all had done for this. All the best to the presenters. Thank you. Get ready, the third group with your project.
Good morning to one and all. Present over here, I am Ananya Kumari along with my teammates Surbi, Shivani, Khushi and Vandana. So here we are going to present a short animated video on schools of math and a class of solid shapes. So without any further delay, let's get into the video.
So here begins our journey, and let us explore the school of maths and the class of solid shapes. At first, here we can see a cuboid who is going to her classroom. Let's talk to her and know about her.
Hi everyone, do you know who I am? Yes, you are correct. I am a cuboid. I am a three-dimensional shape and I have length, width and height as my dimensions. I have 6 faces, 8 vertex and 12 edges. Formula of cuboid. First, area of top and bottom faces is equal to LB plus LB, which is equal to 2LB. Second, area of front and back faces is LH plus LH, which is equal to 2LH. Third, area of side faces is BH plus BH, which is equal to 2BH. Total surface area is 2LB plus 2BH plus 2LH, which is equal to 2 whole LB plus BH plus LH. Lateral surface area is 2BH plus 2LB, which is equal to 2H whole L plus B. Volume of cuboid is L into B into H. Hi, are you a new student?
Yeah, nice to meet you. I'm a solid cylinder. I'm a three-dimensional shape and consists of two parallel bases linked by a closed circular surface where each base is like a circular disc in shape. I have three faces, two edges and 0 vertices. Formulas of solid cylinder. Curved surface area is equals to 2 pi RH square units. Total surface area is equals to CSA plus area of circular base, that is equals to 2 pi RH plus 2 pi R square, that is equals to 2 pi R H plus R square units. Now volume of a solid cylinder is pi R square H.
Hey, why are you both looking little bit identical?
Yeah, because we are twins. Yeah, let me introduce myself. I am a three-dimensional shape and I am empty from inside and have the same difference between internal and external radius. Formulas of hollow cylinder. Curved surface area is equals to internal curved surface area plus external curved surface area is equals to 2 pi RH plus 2 pi RH is equals to 2 pi H into R plus R. Total surface area, curved surface area plus base area is equals to 2 pi H into R plus 2 pi R square minus R square is equals to 2 pi RH plus 2 pi RH plus 2 pi R square minus R square, 2 pi into RH plus R square minus R square, 2 pi into H into R plus R minus R into R plus R, 2 pi into R plus R into R minus R plus H. Volume is equals to pi into R square minus R square into H.
You both are looking pretty.
Thank you. You are beautiful too.
Good morning cube. Meet them. They are solid cylinder and hollow cylinder. And meet her, she is cube.
Oh my god, are they twins?
Yeah.
Nice. I'm a cube and I'm a three-dimensional oval shape. I have 6 faces, 8 vertices and 12 edges. My length, breadth and height are of the same measurement. Formulas of cube are: in cube, A is considered to be length is equal to breadth is equal to height. Total surface area of cube is 2 into A square plus A square plus A square, which is equal to 6A square units. Lateral surface area is 2 into A square plus A square, which is equal to 4A square units. Volume of cube is A cube.
Suddenly, Cone entered into the classroom. Hi all.
Hi.
Are they new students? Yeah. So, let me introduce myself. I am a three-dimensional geometric figure that has a flat surface and a curved surface pointed towards the top. I have one face, 0 edges and 1 vertex. And my formulas are as follows. Total surface area equals to pi into radius into length plus pi into radius square. My volume equals to 1/3 into pi radius square into breadth. and my curved surface area is equals to pi into radius into length. Now all of them take their seats and waiting for their teacher.
Morning all my dear students. I hope that everything is fine and good. So let's start the class with our previous discussion.
So we hope that you all have enjoyed, and we have tried to include art, drama, and the concept of solid shapes in our video.
Hello. Suvi, are you done?
Yes, ma'am.
Okay. Such a nice presentation, huh? Actually, it is executed so nicely with the animation, and it is so very interesting to see. So keep it up, guys. It is been a very illuminating presentation. Thank you all. The factual projects presented over here. So it's time for the third project presentation. Life is like a trigonometric problem. When we start it, every step becomes difficult. At many places, we think, let's quit, do another one. But at the end, we proudly said, henceforth. With this thought, the third group of our students, Madan Mohan Mishra, Priyanshu Naik, Madhushri Manik, Varsarani Khila, Saswati Mishra of the class 10 are going to present their project on the topic trigonometry and its application. Let's welcome them for the presentation. So all the very best to the presenters. The stage is yours. Just fire the stage and let the audience to feel the heat. Get ready, the fourth group of students with your project.
The Theorem and Intersecting morning tells that there is geometry in the moving of the strings. There is a music in the spacing of the sphere. A very good morning to one and all present. I, Madhushri Manik, with my team, welcome you all to the DP Math Calculation. So let's begin.
Mathematics is one of the essential emanations of the human spirit, a thing to be valued in and for itself like art or poetry. With this beautiful quote, I, Priyanshu Naik, welcome you all to today's art integration and experimental learning. Today our topic is trigonometry. Our team, Varsarani Khila, Madan Mohan Mishra, Madhushri Manik, Priyanshu Naik, and Saswati Mishra. Today's contents are introduction, history of trigonometry, application of trigonometry, which consist of marine biology, graph of sin x, graph of cos x. Introduction. Trigonometry is a branch of mathematics dealing with relations involving lengths and angles of triangles. The following are the trigonometric ratios. Sin theta is equal to perpendicular by hypotenuse. Cos theta is equal to base by hypotenuse. Tan theta is equal to perpendicular by base. Cot theta is equal to base by perpendicular. Sec theta is equal to hypotenuse by base. Cosec theta is equal to hypotenuse by perpendicular. Notes: for an angle theta, the side adjacent to it is the base and the side opposite to the angle theta is the perpendicular. With this, I hand over the rest to my co-mate Barsha.
Thank you, Priyanshu. Now let's see the history of trigonometry. The first use of the idea of sine in the way we use it today was in the work Aryabhatyam by Aryabhatta in 8500. Aryabhatta used the word ardhaja for the half curve, which was shortened to ja or jiva in due course. When the Aryabhatyam was translated into Arabic, the word jiva was retained as it is. The word jiva was translated into sinus, which means curve, when the Arabic version was translated into Latin. Soon the word sinus, which is also used as sine, became common in mathematical texts throughout Europe. An English professor of astronomy, Edmund Cantor, first used the abbreviated notation sine. The origin of the term cosine and tangents was much later. The cosine function arose from the need to compute the sine of the complementary angle. Aryabhatta called it cotija. The name cosinus originated with Edmund Cantor. In 1674, the English mathematician Sir Jonas More first used the abbreviated notation cos. Now let's see what are the applications of trigonometry. Trigonometry in criminology. It is even used in the investigation of a crime scene. The functions of trigonometry are helpful to calculate a trajectory of a projectile and to estimate the causes of a collision in a car accident. Trigonometry in marine biology. It is often used by marine biologists for measurements to figure out the depth of sunlight that affects the algae to photosynthesis. Using of trigonometric function and mathematical models, marine biologists estimates the size of larger animals like whales and also understand their behaviors. Trigonometry in navigation. It is also used in navigating directions. It estimates in what direction to place the compass to get a split direction. With the help of a compass and trigonometric functions in navigation, it will easy to pinpoint the location and also to find the distance as well as to see the horizon. Let's see some other uses of trigonometry. It can be used in video games. Mario, the most famous video game, is based on trigonometric functions. Its jump, trajectory, all are measured using trigonometry. Trigonometry is also used in sound waves and light waves. In satellite, trigonometry is also used. Where the satellite is and at what angle, this all can be easily measured using the trigonometry. Exact location or position of the satellite can be easily measured using the trigonometric ratios. Uses of trigonometry in architectural purpose for determining the height of a structure. If architects happen to have the measure of their separation from the said structure along with the knowledge of the angle that forms between the building peak and their eyes, then they can easily implement the tangent function to calculate the height of their buildings accurately up to 2 decimal places. Thank you. Now I request Aswati for further explanation.
Thank you, Prasha. Today, I, Sashwati Mishra, would like to bring a spectacular motif in front of you all. So here, we will link marine biology with trigonometry. So let's proceed. Marine biology is the scientific study of the marine ecosystem, including different types of oceans, tidal zones, etc., along with the features and depth of the ocean beds. For marine biologists, they study biological oceanography and chemical, physical, and geological fields of it to understand marine organisms. For example, marine mammalogy, fishery biology, and marine ecology. So how it is applied? Here we can see the water level is the base of the right angle triangle, which is the adjacent, and the depth of the object is the height opposite to the hypotenuse, and the slant height is the line of the side hypotenuse. and the angle of the depression or angle of elevation depending upon the observer's viewpoint. So let's take an example for more clarity. As we know that the formula for sine theta is equal to perpendicular by hypotenuse. So let's find out the perpendicular length of sine 12 degree with a hypotenuse of 1000 feet. And in the question it is also mentioned that the value of sine 12 degree is equal to 0.208. So let's consider the length of the perpendicular to be x. As sine 12 degree is equal to x by 1000, hence we'll take value of x is equal to 208 feet. Now I hand over rest of my part to my co-mate Madhushri.
Thank you, Saraswati. Let us see the graph of sin x and cos x. From this graph, we will find out two things about the function sin x and cos x. First, maximum and minimum. Second, increasing and decreasing. First of all, let's see the graph of sin x. Since sin x is a periodic function with period 2 pi, so we will draw the graph of y equal to sin x in the interval 0, 2 pi. In order to draw the graph of y equal to sin x in the interval 0, 2 pi, we first draw it in 0, pi by 2. The value of sin x for different value of x in the interval 0, pi by 2. When the angle is in between 0 degree to 90 degree, then the graph goes upward, which shows the value of sin x increasing. And when the angle is in between 90 degree to 180 degree and in between 180 degree to 270 degree, the graph decreases. When the angle is in between 270 degree to 360 degree, the graph goes upward and it shows that the value of sin x is increasing. In this, we often that sin x is an increasing function for 0 degree to 90 degree. In this graph, we also find out the maximum and minimum value. Here, maximum value is 1 at theta is equal to pi by 2 and minimum value is minus 1 at theta 3 pi by 2. Now I request my co-mate Madan for further explanation.
Now let us see the graph of cos x. Since cos x is a periodic function with period 2 pi, so it is sufficient to draw the graph in the interval 0, 2 pi. As you all can see, when angle is 0 degree to 90 degree, the graph goes downward, which shows the value of cos x decreases. Similarly, when the angle 90 degree to 180 degree, the value of cos x is decreasing. But when the angle 180 to 270 degree, the graph goes upward, which shows the value of cos x increasing. Similarly, in the case of angle between 270 degree to 360 degree. In this graph, we also find out the maximum and minimum value of cos x. Here, maximum value is 1. Now, minimum value is minus. Thank you for your patience hearing.
I remain most grateful for your rapt attention. I hope you have learned something from it. Thank you. Have a nice day.
Thank you so much, all the presenters. Such a blissful and faultless presentation it was. You all nicely explained the history of trigonometry, application of trigonometry in marine biology, and I just know today that how the trigonometry is used in my most favorite game, Mario. And you all nicely explained the trigonometric ratios with their periods, the sin x and cos x. Very well done. Keep it up, guys. It is time for our next project. From the word circle, a thought comes to my mind, that is, life is a circle of happiness, sadness, hard times, and good times. If you are going through hard times, have faith that good times are on the way. On this positive note, let us invite our next presenters, the students Aditya N. Rao, Ayush R. Pradhan, Mayank Jha, Surya M. Singh, Satyajit Bari of class 10 to present their project on the topic circle. According to George Cantor, the essence of mathematics lies in its freedom. So all the very best to this group. Just grab the stage and play your music and allow the audience to enjoy it. Get ready, the next group with your project.
Good morning to all. Good morning to all. I am Surya Narayan Singh, and with my teammates Aditya Narayan Rao, Mayank Jha, Satyajit Bari, in the guidance of Jeevan Jyoti sir, we are trying to give you some more information about circle. So we will start our PPT with a beautiful quote, "Life is a circle. The end of one journey is the beginning of the other one." So the content we are discussing in our PPT are about circle, the important lines of circle, then the third part is art integration, and the fourth part is fun facts. So we are discussing about circle. So what this image have common in that? Yes, you guessed it right. The four images are in the circular shape. So area and perimeter of a circle. So what is an area of a circle? It means that the total area covered by the circle on a plane. The formula of area of circle is pi r square, in which r stands for the radius. And the circumference of circle, which is also known as the perimeter of circle, is the total length of its boundary. And the formula is 2 pi r, in which r stands for the radius of a circle. Then we are discussing about area and perimeter of circle. First, before we going for the area and perimeter, first we will discuss about sector. So what is a sector? It is a part of a circle which is bounded by the two radius and an arc. And the formula for it is theta by 360 into pi r square, with the angle between the radius is known as theta. And the perimeter formula is theta by 360 into 2 pi r. And the theta is the angle between the radius. So now I am handovering the PPT to my friend Satyajit to give you information about the important lines of the circle.
Thank you, Surya. Good morning to all. So you might be getting confused in lines in a circle. So I will clear it all. First comes secant. Secant is a line segment that intersects circle at two distinct points. In a circle, there are infinite number of secants. Now, tangent. That intersect circle at one point. Now it comes chord. Chord is a line segment which joining any 2 points of a circle. The longest chord is known as diameter. There is one theorem, let's know it out. If two chords of a circle intersect each other, then the product of their length, of their segment is equal. So from now, my friend Mayank will take the in charge of the presentation.
Thank you, Satyajit, for giving me this opportunity. So today I will give you the basic knowledge of and one property of tangent by the help of a poem. A tangent, a line, and a circle. A point outside a circle shoots out two lines, one heading for the center, the other moves a line. Smoothly kisses the curve that delicate serve of the ball and then abruptly turns to the center, makes an angle and meets the first, which went to the straight to thus form a triangle. This angle formed by the tangent and the other line, the radius, the mathematical mind says is exactly 90 degrees. The poem means to say that the radius is perpendicular to the tangent. That means where the tangent intersects the circle, that angle is 90 degrees. So now I would like to call my friend Aditya to give you some interesting facts about pi and a circle.
Thank you, Mayank, for handovering this PPT. Now, let's know some fun facts about circle and which is related to pi. Pi is very important in math because pi is natural, irrational, and very important in mathematics. And do you know pi is the 16th letter of Greek alphabet and pi is the ratio of any circle circumference to its diameter. You can't know about circle without pi. Now, let's know something about Pi Day. Pi Day is celebrated on March, abbreviated as 3.14, whereas 3 represents the month March and 14 the day. Even Albert Einstein, also born on that day, his birthday is on 14th March 1879, and Stephen Hawking died on this day. In 2009, Congress finally declared March 14 as the Pi Day and recognition of importance of math, science, and education to Pi. Now I hand over this PPT to Mayank.
So our team thought of a plan. So we will give you some extra gyan in our next segment, that is bonus gyan about locus. Mathematics is not about numbers, equations, computations, or algorithms. It is about understanding. So let's know something extra. Let's do an activity to know about locus. So locus, introduction. It can be said that whenever a set of points satisfying a certain conditions are plotted, a pattern is formed. This pattern formed by all possible points satisfying the given condition is called the locus of points. In the above given example, we have a locus of points which are equidistant from the point O. So the definition of locus will be the collection or sets of points satisfying certain given geometrical conditions, and it is called the locus of a point. There is a theorem of locus in circle that the locus of point in a plane which is at a constant distance r from a fixed point O is a circle with center O and radius r. And please note one thing, the locus for different figures are different.
So this is the knowledgeable end of our PPT. So we are grateful to you for being a patient listener. Thank you to all.
Is it over, guys?
Yes, ma'am.
Yes, ma'am.
Yes,
Okay, okay. Thank you so much, all the presenters, for the wonderful presentation. Nicely explained about the circles and pi and locus of points. And that poem was such a wonderful poem. Huh? So keep it up, guys. I hope we will see some more interesting projects from you guys. Thank you so much. It's time for our fifth project. Life is like a math equation. In order to gain the most, you have to know how to convert the negative into positive. With this thought, our students Rani Pale, Shruti Mahapatra, Divyajit Chaudhary, Sumit Kar, Divyanshu Das of class 9 are going to present a project on the topic use of mathematics in everyday life. Please welcome all the presenters of this group. Now the stage is yours. All the best. Just rock the stage.
Good morning, everyone. Uh, our team welcomes you all to this virtual Math Explorer. We have made a video on the topic Use of Math in Daily Life under the guidance of Jivan Jyoti sir. So now let's start our video.
Good morning, everyone. Our team welcomes you all in this virtual platform. We all would like to share our views on the topic use of maths in everyday life. Now, I would like to show you all some uses of math in the field of art. So, let's start. First, let's know about Mandala Art. As we all know that Mandala Art are very famous since ancient times. This art form is rich in mathematics. It provides us useful practice with geometric tools, including rulers, compass, protractors. Mandala translates complex mathematical expressions into simple shapes and forms.
Now, let us know about Valli art. As we all know that Valli art are very famous in tribal areas. This is a simple and linear 2D art form with the maximum uses of triangular shapes. Valli art is a beautiful folk art of Maharashtra. Valli paintings uses geometric shapes, mostly a circle, a square and a triangle. These shapes symbolize the different shapes of the nature.
Now let's see some uses of math in graph. As we know that stock market is very famous nowadays and investors invest in stock market by reading graphs of the stocks. This also helps them to identify price patterns in the stock market and make better trading decisions. Some common type of stock market graph presentations include bar charts, candlestick charts, points and figure charts.
So it's time to see some uses of probability in real life. At a given ball with a certain number of runs remaining, we can compute the probability of which team will lose. Using the probabilities of various outcomes during that ball, possible outcomes include a wicket falling, no run being scored, one run being scored, and so on. Each game you play at a casino has a statistical probability against your winning. The probability of winning is 1 by 5,000 of winning the top race. The winning also depends on the amount of bidding.
So now it's time to know about the use of math in architectures. Architects use geometry to lay the foundation of the building. They also used mathematical objects such as tessellation to decorate buildings, and also tessellations are used in the process of tiles making. The Leaning Tower of Pisa, one of the 7 wonders of the world, is built by using geometry and trigonometry. Thank you all for watching our video. Wish you all a happy day ahead.
So now it's time for a quiz. We have sent you all a quiz link so that you can join the live quiz.
Is it over?
No, madam, they have to go for a quiz.
Okay.
Thank you each and everyone for being with us today.
Thank you so much. Congratulations, all the winners. Nicely explained how mathematics is used in Mandala Art, Valli Art, and you also nicely explained how the mapping of graphs and probability are used in our day-to-day life in different different areas. Okay, so thank you for the nice presentation. You are presented.
Thank you, ma'am.
You were presented here. Thank you so much. Now it's time for a quiz.
Thank you,
Before
ma'am.
I hand, thank you so much. Before I hand over the platform to our beloved Rimama, I just want to add something here. Man is like a fraction, whose numerator is what he is, and whose denominator is what he thinks of himself. Hence, the larger the denominator, the smaller the fraction. Thank you all for having me. All the best, students. Thank you so much. It's over to you, ma'am.
Okay. Thank you, Parasimita ma'am. Hope you all get refreshed. Let's move to our sun is round, our planet is round. So let's welcome B square plus J plus S group, that is Vishnu, Bibu, Jyotiraditya and Siddesh with the topic circle and its theorem. Yes, sir?
Sorry to interrupt.
Okay.
Quiz is there by.
Okay, quiz. Okay, sorry for that one. Okay, let's welcome Supriya. Okay, now she is with some quiz. Now, Supriya, welcome and play and ask some question to the students and test whether they know or not. Okay, Supriya, welcome. Supriya, are you here? Are you here? Jeevan Jyoti, sir?
I think.
Ma'am, am I audible?
Okay, Supriya. Yes, you are audible. Now let's start.
Experiential learning is the process of learning by doing. By engaging students in hands-on experiences and reflection, they are better able to connect theories and knowledge learned in the classroom to the real-world situations. So, without wasting much time, let's begin our experiential learning session. I hand over the rest of the part to Jeevan sir. So, please.
Okay. Now, hope you all get refreshed by playing this quiz. So let's move to our next presentation. Round, round everywhere. Sun is round, our planet is round. So let's welcome B square J plus S group, that is Vishnu, Bibhu, Jyotiraditya and Siddhesh with the topic circle and its theorem. Now welcome you all. Unmute yourself and start your presentation. Vishnu?
Yes, ma'am. Ma'am, am I audible?
Now start. Yes, you are audible.
Excuse me, sir. Sir, we have to make our video on.
It will be better, Vishnu.
If it is possible, then.
Hello.
It will be better if you can.
Okay, sir. I'm trying to make. Yes, sir. I'm trying to. Sir, is my screen visible?
Yes, your screen is visible. Now start.
Good morning, everyone, to our presentation. My name is Vishnu Prasad, Mr. from class 9, and today me and my team is going to represent the presentation on the topic circle and its theorems. So let's get started with our presentation. Excuse me, sir?
Yes, Vishnu. Better turn off your video.
Sir, I think it's network problem. Yes,
turn
sir.
off your
Sir,
video.
I think it's network problem. So, please, you can, if you can share, please share, sir.
Okay, you can turn off your video. Okay, I'm sharing.
Yes, sir.
Now you can start, Vishnu.
Yes, sir. सर थोड़ा स्लाइड्स तो शुरू कर दीजिए. And we are on the topic circle and its theorems. Sir, please next slide.
Vishnu, kindly make it brief, eh?
Yes, sir. Our team is me and my friend Bibhu, Siddhesh and Jyoti, and we are from class 9, and under the guidance of Mr. Jeevan sir, we have made this project on the topic circle and its theorems. Now before going into the topic, let's see what a circle. A circle is a shape consisting of all points in a plane that are at a given distance from a given point, the center. Equivalently, it is the curve traced out by a point that moves in a plane so that its distance from a given point is constant. Here you can see the tangent, secant chord, etc. Now before going into the topic, let's know what a theorem is. A theorem is a given statement which you have to prove within the given information. Now let's start the topic, the theorems. But before that we have to know the criteria for congruency, that are angle, angle, side, angle, etc. Say these are similar, side, 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 side angle, side, right angle, hypotenuse, side. Now I'll be thinking that why are these criteria for congruency important in circles as these are used in triangle? So I tell you that to prove these theorems of circle we need these criteria for congruency. Please listen to this carefully as we will ask on this presentation after this get over. Something about the circle theorems. Circle theorem includes the concept of tangents, sectors, angles, the chord of a circle, and proofs. A circle is the locus of all points in a plane which are equidistant from a given point. The fixed point is called the center of the circle, and the constant distance between any point on the circle is and its center is called the radius. The perimeter of a circle is known as the circumference of circle, and the area occupied by a circle in a plane is its area. The tangent is perpendicular to the radius at any point of circle to the point of contact. Let us learn more about the circle and its theorems here. Now let's see theorem number 1. Equal chords of a circle subtend equal angles at the center. Now let's prove this theorem number 1. Given is chord AB is equal to chord CD to prove angle AOB and angle COD, and we have took out the same like to prove the triangles, and hence triangle AOB is congruent to triangle COD, and angle AOB is equal to angle COD by CACT, which is also known as CPCT. Now let's go to the theorem number 2. If the angles subtended by the chords of circle at the center are equal, then the chords are equal. So to prove it, given is angle AOB is equal to angle COD. To prove angle AOB is equal to chord, to prove chord AB is equal to chord CD by using the similar sides or angles in the triangle, angle AOB is congruent to angle COD by SAS test or SAS criteria. Hence chord AB is equal to chord CD by CPCT or CACT. Now I'll hand over this PPT to my friend Bibu to take this PPT forward for further explanation.
Thank you, Vishnu. Good morning to all present over here. Now I am going to explain from Theorem 3. In Theorem 3, it is given that the perpendicular from the center of the circle to a chord bisects the chord. To prove it, BD equal to BC. Here two triangles, triangle ADB and triangle ADC are given. These two are congruent by RHS criteria of congruency. So by CSCT, BD equal to DC. So please move to next slide. So Theorem 4. In Theorem 4, it is given that the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. Here you have to prove that AD is perpendicular to BC. Here triangle ADB is congruent to triangle ADC by SS criteria of congruency. Angle ADB equal to 90 degree equal to angle ADC. Now let's move to Theorem 5. In Theorem 5, it is given that there is only one circle passing through three given non-collinear points. Here we have to take three different points. We need a center and radius. two perpendicular bisectors are taken, we take a common point O and form a circle. So a circle is formed using three given non-collinear points. Now let's move to Theorem 6. In Theorem 6, it is given that equal chords of a circle or of congruent circle are equidistant from the center. Here you have to prove that OE equal to OF. In triangle AEO and triangle CFO, both are congruent by RHS criteria of congruency. So OE equal to OF. Now let's move to Theorem 7. In Theorem 7, it is given that chords equidistant from the center of a circle are equal in length. Here you have to prove that chord AB equal to chord CD. Here triangle AO and triangle CFO are congruent by RHS criteria of congruency. So chord AB equal to chord CD. Now I would like to request my partner Sidhesh to explain further.
Thank you, Vibhu. Now we are at Theorem 8, which mentions the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. We have to prove that angle BOC is equal to angle BAC. For this, in angle AOB, angle AO, and side AO is equal to side OB, as they are the radii of the same circle. Let angle BAO equal to angle ABO equal to X. Then angle BOD is equal to angle BAO plus angle BABO. So it is 2X. In triangle AOC, angle CAO is equal to angle ACO. Let it be Y. So we know that angle COD is equal to angle CAO plus angle AC. So it will be 2Y. In the figure, we can see that angle BAC is equal to X plus Y. So angle BO and angle BOC is equal to angle BOD plus angle COD. As we had derived earlier, angle BOD is 2x and angle COD is 2y. So we will take 2 common. So it will be angle 2 into x plus y. As x plus y is angle BAC, so we had proved that angle BOC is equal to 2 times of angle BAC. Theorem 9. Angles in a same segment of a circle are equal. Means angle in this figure, we have to prove that angle BAC is equal to angle BFC is equal to angle BGC. From Theorem 8, we can prove angle BAC is equal to half of angle BOC because of Theorem 8, let it be 1. Then angle BFC is equal to half of angle BOC from the Theorem 8, let it be equation 2. Angle BGC is equal to half of angle BOC from Theorem 8. From these three equations, we finally conclude that angle BAC is equal to angle BFC is equal to angle BGC. So angle BAC is equal to 90 degrees. With this, we can also prove that angle subtended in a semicircle is a right angle, as we can see in the figure. Angle BOC is equal to 180 degrees. So by Theorem 8, its half will be angle BAC, which is 90 degrees. On to the next one, Theorem 10. Here it is mentioned that if an line segment joins 2 points subtended equal angles at two other points lying on the same side of the line containing the line segment, the 4 points lie on a circle. To prove that, here we have angle ACB is equal to angle ADB. For this, we have to draw a circle passing through point A, B, and C. It is given that angle ACB is equal to angle ADB. If the point D is lying outside the circle, let's say it is B dash, from given, we know that angle ACB will be equal to angle AD dash B. It is only possible when point D dash is lying on point D. So it proves that all the points are lying on a circle. From this, we can also derive that a quadrilateral having 4 points on a circle is called a cyclic quadrilateral. From here, I would like to ask Jyotiraditya to continue the presentation.
Jyotiraditya, are you here?
यस सर वो है सर
anyone of
दो डिवाइसेस ज्वाइन किए हैं
still he is not unmuting. So anyone of you just go for it.
Yes, sir. In theorem 11, we have sum of a pair of opposite angles of a cyclic quadrilateral is 180 degrees. So to prove this, here it is given that an ABCD quadrilateral is a cyclic quadrilateral. We have to prove angle A plus angle D is equal to 180 degree and angle B plus angle C is equal to 180 degree. According to the inscripted angle theorem, angle A is equal to half meter, 2A is equal to half m, angle D is equal to half m, 2D is equal to m. M, which is arc CDB plus m, which is arc CAB, is equal to 2 angle A plus 2 angle D, which is equal to 360 degrees. So if we will, so from this we have derived angle A plus angle D is equal to 180 degrees. We can prove angle B plus angle C is equal to 180 degrees by the same process. Theorem 12. If the sum of a pair of opposite angles of a quadrilateral is 180 degrees, the quadrilateral is cyclic. This is the converse of Theorem 11. We can prove this Theorem 12 by the same process of Theorem 10. Now, to summarize, the first theorem was equal chord of a circle subtend equal angles at the center. Theorem 2 was if the angle subtended by the chord of a circle at the center are equal, then the chords are equal. It is the converse of theorem 1. Third theorem was the perpendicular from center of a circle to a chord bisect the chord. Then theorem 4, the line drawn through the center of the circle to bisect a chord is perpendicular to the chord. This is the converse of theorem 3. Then theorem number 6, equal chord of a circle or of a congruent circle are equidistant from the center. Then the next one was chords equidistant from the center of the circle are of equal length. We can prove theorem 1 to theorem 7 by the help of congruency criteria. In theorem 5, it was there is one and only circle passing through three given non-Cordilleran points. This can be proved by geometric construction. Then theorem 8 was angle subtended by R at the center is double the angle subtended by it at any point on the remaining part of the circle. We had proved this by the exterior angle theorem. We can also say this theorem as 2/1 theorem because the ratio of the angles will be 2/1 in it. Then theorem 9 says angles in same segment of a circle are equal. Theorem 10 is if a line segment joins 2 points subtended equal to other 2 points lying on the same side of the line containing the line segment, then the 4 points lie on a circle. Theorem 11 is the sum of pair of opposite angles of a cyclic quadrature are 180 degrees. Then theorem 12 is the inverse of theorem 11. These four theorems can be proved by using theorem 8 and they're based on theorem 8. So please next slide.
Make it brief, students. I already have taken lots of time. Make it brief.
From here, I would like to ask Vishnu to continue forward.
Thanks, Hitesh. And I'm going to tell you the day-to-day applications for circle. Circle is frequently used in architecture. One application of circle in science lies in the design of particle separators. The invention of a wheel remains one of the most important inventions of all time. This circle is made it possible for people to move things at greater distances at faster speeds. Circles are still symbolically important today. They are often used to symbolize harmony and unity. For instance, take a look at the Olympic symbol. Sir, please display all the pictures. It has 5 interlocking rings of different colors which represents 5 major continents of the world united together in a spirit of healthy competition. Circles are special ellipses that have a single constant radius around a center. Circles and their various properties such as the radius, diameter, circumference and the area have applications in real life. If the radius of a circle is not known, all other parameters can be calculated. But if it's known, then all other can be calculated. Important information can be determined. No sir, only 10 minutes, only 10 questions are there. Important informations can be determined for real life applications based on parameters. For example, knowing the circumference of all planets helps us to compare the relative sizes and artificial satellites that are launched travel in orbits in a certain circumference. The radius of a curvature of a camera lens can be used to determine its focal length, which is the distance from the lens from the light rays focus. Pizza and cake size are determined by the diameter of the pan in which they are baked, and the distance traveled by a person sitting on a Ferris wheel can be determined by calculating the circumference of the wheel. The tires of a different vehicle have different radii. The circumference of ring needs to match the circumference of the finger on which it is worn for a good fit. Yes, sir.
How to
सर
share the quiz? I am sharing
सर
it.
मैं चैट बॉक्स में भेज दूंगा सर. ये वाला लिंक कल हुआ था ना, आज तक बंद हो गया होगा.
So better to skip it, okay? Vishnu?
सर रखा हूँ, अभी भेज दूंगा.
Okay, okay. You send it later and end your presentation.
Yes, sir.
Now it is over. Okay. Thank you for the nice presentation. Good, keep it up. Now here is one riddle for you all. It is just to guess which topic will be the next one. Okay. Here is one riddle for you all. Just to guess which topic will be the next one. Okay. Now your sign caused a rapid flow of blood under my cheeks, coating a virtual tan which eventually lasts for a second. Is there any idea which topic will be the next one?
Ma'am,
No?
trigonometry.
Very good. It is very good. It is none other than trigonometry. So let's welcome Ritu, Anushka, Samarika and Janvi to represent trigonometry. Okay, now welcome you all guys.
Yes, ma'am.
Now unmute yourself and start.
Ma'am, am I visible and audible?
Yes, you are all visible and audible.
Yes, ma'am. Mathematics is full of fun with so much to learn. Profits are added while losses are subtracted. Degrees are multiplied and percentage is divided. Geometry is full of mystery. Algebra has a big history. Integers are as different as our brothers. Lines are parallel. Angles are similar. Math is necessary in life. Without it, it is difficult to survive. Good morning to one and all present over here. Today, I and my companions, Smarnika, Anushka, and Ritu Kumari, are going to give you a glimpse of such a fabulous topic, trigonometry. So before going to the topic, I would like to invite a short written poem on trigonometry. The poem is, the cos rule requires a little invention. The Pythagoras rule with a little extension takes away the 2bc. Cos A is not right. Across from big a little takes a flight. Now I would like Jeevan Jyoti sir to play of our video.
Trigonometry, the branch of mathematics concerned with specific functions of angles and their applications to calculations. There are 6 functions of an angle commonly used in trigonometry. Every triangle has 6 parts, 3 angles and 3 sides. If you measure the sides and then pair up those measurements taking 2 at a time, you have 3 different pairings, 2 divisible problems with the pairings changing in order to each pair, and you have 6 different answers. The 6 different answers are sine, cosine, tangent, cotangent, secant, and cosecant. The word trigonometry comes from the Greek words tri, gono, and metron. Tri means 3, gono means sides, and metron means to measure. Until about the 16th century, trigonometry was chiefly concerned with the computing the numerical values of missing parts of a triangle when the values of other parts were given. For example, if the length of two sides of triangle and the measure of the enclosed angle are known, the third side and the two remaining angles can be calculated. Such calculations distinguish trigonometry from geometry. In Egypt and the Mediterranean world, several ancient civilizations, in particular the Egyptians, Babylonians, Hindus, and Chinese, possessed a considerable knowledge of practical geometry, including some concepts that were a prelude to geometry. The Rin-Paras, an Egyptian collection of 84 problems in arithmetic algebra and geometry dating from about 1800 BC, contains 5 problems dealing with the sect. Also, a close analysis of the text with its accompanying figures reveals that this word means the slope of an incline, essential knowledge for huge construction projects such as the pyramid. For example, the problem 56 asks, if a pyramid is 250 cubits high and the side of its base is 360 cubits long, what is its sect? The solution is given as 125 palms per cubit, and since 1 palms, the fraction is equivalent to the pure ratio 18/25. This is actually the run to rise ratio of the pyramid in question. Ineffective. The cotangent of
in general, the law of sines is defined by as the ratio of side run to the sine of opposite angle. It holds for all the three sides of a triangle, respective of their sides and angles. It works for any triangle A sine A equal to B sine B equal to C sine C. The law of sine is explained in detail as follows. In a triangle, side A divided by the sine of angle A is equal to the side B divided by the sine of angle B is equal to the side C divided by the sine of angle. We use the sine rule to find unknown lengths or angle of triangle. It is also called as sine rule, sine law, or sine formula. By finding the unknown angles of a triangle, the law of sine formula can be written as follows: sine A by A equal to sine B by B equal to sine C by C. In this case, the fraction is interchanged. It means that sine A by A instead of taking A by sine. Law of cosines. In trigonometry, the law of cosines, also known as cosine rule or cosine formula, basically related the length of triangle to cosines of one of its angles. It states that if the length of two sides and angle between them is known for a triangle, then we can determine the length of the third side. It is given by c to the power 2 equal to a to the power 2 plus b to the power 2 minus 2ab cos c gamma, where a, b and c are the side of a triangle and gamma is the angle between a and b.
So these are some identities and formulas which are to be marked. Between an archer and his arrow. Once an arrow asked an archer, "How you always get me hit the target perfectly? How do each time you find the accurate angle to release me to exact point? You always amaze me with your skill." The archer grinned and uttered, "Oh my little arrow, it's no big deal, but a minor computation be done." And started, "Consider the distance between my hand and the target board as perpendicular distance of a right angle triangle, and my hand with the center of the target as hypotenuse of the right triangle. And if we know the value of these two sides, trigonometry makes it too easier for us to calculate it. Let the unknown angle be the theta. Sin theta is equal to perpendicular by hypotenuse. Finally, theta is equal to perpendicular by hypotenuse into 1 by sin theta. And this is how I amaze you by hitting you to exact point." A poem of trigonometry. The interesting ratios of trigonometry is found to be tricky for pupils of matric. Sine is the protagonist of this lyrical poem. It started from a point, then turns right and found his brother Mr. Cossack Bite, having a relation of reciprocity. theta, tan theta is equal to 1 by cot theta. Now this is the end of your subsequently, but also have relation between angles complementary. Sin theta is equal to cos 90 minus theta, cosec theta is equal to sec 90 minus theta, tan theta is equal to cot 90 minus theta, and similar for cos theta, sec theta and cot theta. There are trigonometric identities to be covered which get mucked up when hair freezes over. That are sin square theta plus cos square theta is equal to 1, sec square theta minus tan square theta is equal to 1, cosec square theta minus cot square theta is equal to 1. Circle. We know that there are three basic trigonometric functions, that are sin theta, cos theta and tan theta. Then how are these three trigonometric functions related to angle theta? What happens to them when theta changes? Are they directly or inversely proportional to angle theta? This can be answered by the concept of unit circle. A unit circle is a circle with radius 1 unit with its center at origin 0, 0 that is drawn in a Cartesian plane. The interior of the unit circle is called open unit disk, and the interior of the unit circle combined with the unit circle itself is called the closed unit disk. Consider here a right angle triangle with hypotenuse 1 unit and the length of the perpendicular y and base be x units. Therefore, we can write the trigonometric ratios as sin theta is equal to y by 1 is equal to y, cos theta is equal to x by 1 is equal to x, and tan theta is equal to y by x. And another observation that can be recorded in first quadrant is that when theta increases, tan and sine also increases but cos decreases. And when theta is equal to 90 degree, tan theta is equal to 1, that is the radius, and cos theta is equal to 1, and tan theta can't be defined. So it gives us our trigonometric functions that we know, that is sin square theta plus cos square theta is equal to 1.
Very good, guys. You beautifully explained that topic. Very good. Keep it up. Now, art is the ultimate method of human communication, and how we will integrate in mathematics is beautifully explained in our next topic, which is going to represent by 2A plus 2S group, that is Ankita, Ayushi, Soumya, and Subhasri. So, guys, unmute yourself and let's start.
Math may
Guys,
not
are you
teach us
ready?
how to. Yes, ma'am.
Okay.
Math may not teach us how
Yes,
to
yes,
add
start,
up
start.
and subtract it. Math may not teach us how to add up and subtract it, but it gives us hope that each and every problem has a solution. With this beautiful thought, I am Soumya Panda with my whole team members going to present our presentation based on art and integration of integrated worldly art and mathematics. So friends, let's enjoy our presentation.
Any problems, Subhasri? Subhasri, is there any problem?
I think Jeevan sir, Subhasri has some network problem.
Subhasri, then just stop sharing. Let me share. Yuvasri, stop sharing.
Respected sir and one and all present over here. Today I, Subhashri Samar, with my group members Ankita Datta, Ayushi Gupta and Soumya Panda will present our math activity. So now we're gonna be dive with the most beautiful combination that exists. But wait, what we are talking about here? Yes, none other than but the integration of body art and mathematics. Well, still seems to be confused. Why? Don't worry, let's explore this amazing combination and concept behind it together.
Content: How worldly art is linked with mathematics. Comparison between worldly art Maharashtra and Saura art Odisha. Mathematical concept used in worldly art. How worldly art is linked with mathematics. The word worldly comes from the word Varla, which means piece of land. This art is a two-dimensional with no perspective or proportion. Worldly painting uses geometric designs such as triangles, circles, dots, squares, and lines to depict the human figure, house, and daily work of hunting, dancing, sowing, harvesting, etc.
Worldly art. The worldly tribal art originated near the coastal areas of Maharashtra around the 10th century AD. The background of worldly art was always in red arc and the figures made using a white pigment which is prepared using rice paste. The characteristics figures which are featured in figures of worldly art are thus a circle, a triangle, and a square. The worldly covers themes like festivals, hunting, fishing, dancing, animals, and trees. Swara art. The Saura tribal art came into being in Odisha and can be traced as back as the time period of Ramayana and Mahabharata. The background color is chosen from among the red ochre, yellow ochre, and white, and the figures are made using hues of blue, green, white, red, and yellow. The Saura art also does not have figures as sharp as worldly art. Saura art is made primarily for the religious purpose and featured ideal the trees of life in addition to human and animal figures. What are the mathematical concepts used here? Intersecting line, parallel line, triangles, and the circle.
Intersecting lines. Friends, in your mind, first question arises that what is intersecting line? Intersecting line is the two or more lines which share exactly one common point are called intersecting lines. In this worldly art, you can see that these two lines are intersect to each other because they have one common point. And here also one example given, and this is a complete angle, and the total the sum of all the angle will be 360 degrees, and the angles given are 75 degree, 47 degree, 83 degree, and 92 degree, and we have to find x. The sum of all the angles is 297 degree and x is equal to 63 degree. Parallel lines. What is parallel lines? When two or more lines that lie in the same plane and never intersect or meet each other are known as parallel lines. In this worldly art, the legs of the man, you can see that there in each leg there are two lines, and in two legs the four lines are parallel to each other. Here also one example given, line L, M and N given, and T is their transversal, and angle 1, 2, 3 given, and L is parallel to M and M is parallel to N, and T is transversal, and we have to prove L is parallel to N. Then prove angle 1 is equal to angle 2 because corresponding angle, and angle 2 is equal to angle 3 because it is also corresponding angle. From equation 1 and 2 we find that angle 1 is equal to angle 3 because these are also corresponding angles. So hence it's proved.
A triangle is defined as a three-side two-dimensional figure whose interior angles are equal to 180 degrees. So in this picture you can see the body of the people are made up of triangle. So let's consider one example. Here I have taken a triangle. Angle A is equal to 84 degree, angle B is equal to 43 degree, and we have to find angle C. By triangle angle sum theorem, 84 degree plus 43 degree plus C is equal to 180 degree. By simplifying we get angle C is equal to 53 degree. Circle. A circle is a round shaped figure that has no corners or edges. So let's consider one example. The difference between the circumference and the diameter of the circle is 5 cm. So we have to find the radius of the circle. Let the radius of the circle be r. According to the question, circumference minus diameter is equal to 5 cm. We know that circumference of a circle equal to 2 pi r, diameter of a circle 2r. Therefore 2 pi r minus 2r is equal to 5 cm. By taking 2r common, pi minus 1 is equal to 5 cm. After solving this, we get the radius of the circle is 1.166 cm. I hope this presentation gave you the opportunity to widen the knowledge in both the field of mathematics and art. And I would like to thank Jeevan Jyoti sir for giving this opportunity. And finally, thank you all for giving your precious time. Thank you.
Thank you all for your active participation and support. I will.
Very good, girls.
I think that
very informative and interesting presentation. Okay. Okay, Soumya, it is over. Soumya?
Yes, ma'am. Yes, ma'am, it's over.
Okay, now very good, girls. It is a very informative and interesting presentation. Now let's move to the next presentation. Life is a linear equation in which you can't cross multiply. Okay, if you think you can do it, then you can do it. If you think you can't do it, then you can't do it. It is just a simple formula. So let's welcome our next pentagonal group, Vivekanand, Swapnesh, Swastik, Amlan, and Pratyush with the topic linear equation in two variables. Boys, let's start.
Yes, ma'am. A warm and cheerful good morning to one and all present over here. Today I am Vivekanand Tripathi and I'm not to introduce our topic. So without wasting our time, let's get into the video. Ma'am, is the voice audible?
Yes, it is audible and visible also. Now start. Vivekanand. Okay, now start.
Yes, ma'am. Okay, ma'am.
Mathematics, in its way, is a poetry of logical ideas. Without mathematics, there is nothing we can do. Everything around us is mathematics. Thought, good morning to one and all present over here. Respected principal, sir, dignified teachers, and all my dear friends.
Vivekanand, there's lots of network problem you are having. The video is not coming.
On the topic,
Sir,
should I go for
so
it?
वो आपको सेंड किया था
Should I go for it?
सर वो आपको
Okay, okay. I'm sharing. Okay.
the poetry of logical ideas. Without mathematics, there is nothing we can do. Everything around us is mathematics. Everything around us is numbers. With this beautiful thought, good morning to one and all present over here. Respected principal sir, dignified teachers, and all my dear friends. Myself Swastik Kar of class 10th, here with my team, going to spread some ideas on the topic equation. So before starting our presentation, I would like to take some few moments and thank you to our teacher Jivan Jyoti sir, who guided us in each and every part of this presentation. So in this presentation, we would be discussing about equation. First of all, we would be starting with introduction of equation, followed by types of equation. Then we will discuss about linear equation in one variable, which would be followed by linear equation in two variables, and these two parts would be including their uses, operations, solutions, and much more. Then we would move towards quadratic equation, and at last